So what will end up happening on this one is, if I try to add down, what I'm going to find is none of my variables are going to disappear at all. Well, that's not good, because I have to have one of them disappear, because otherwise I can't solve for this. So I need an option to be able to do this. Because if I were to add down right here, well, 2x and 1x would be 3x. Negative 4 plus 3y would be a negative y. And 10 plus 15 would be 25. That doesn't make me real happy because, well, one of my variables didn't go away. So here's how this is going to work. We're going to find one of the equations where I just see x or just see y. So in this particular one, right here, I see there's just an x. So I'm going to kind of turn this into what I want it to be. And here's how this works. You know what would be cool is, if this is 2x, I'd like this to be negative 2x, because then when I add them up, they'd cancel, sort of like that one that I had up here. So what I'm allowed to do is multiply an entire equation by that number. So here's how this works. If I want this to be negative 2x, so they cancel, I can multiply everything here by negative 2. By doing that, and again, it's not just the x I got to multiply by. It's everything. So I get negative 2x, negative 2 times 3, and I'll explain where I figure out the number here again in just a minute. It would be negative 6y, and negative 2 times 15 is negative 30. And what's nice is, once I distribute and multiply that through, now I can add down 2x plus negative 2x cancels, like it did yesterday. Negative 4 plus negative 6 is a negative 10y, and 10 plus negative 30 is negative 20. I divide by negative 10, which is my one step to get y alone, I get my y value. And then, similar to what we did yesterday, I can plug my y value back in to either one of the equations, so I get rid of the y. Go a little bigger yet here. Plug it in, and then I can solve that equation. Now, is this a little longer than yesterday's? Yes, there's one extra step. But it's still shorter for the most part than the full-blown substitution is going to be. So here's how this is going to work. I will even help on which ones we're going to multiply with. When we get down to the bottom, my first job, anytime I look right away, is to try and add down. If I can add down and everything, and a variable disappears, that's awesome. But in this case, I look, I'm like, 3 and negative 1, nope, that's not going to cancel. 2 and 3, nope, that's not going to cancel. So I got to do something. Well, if I do 2 plus 3, what do I get? 5. So is it gone? No. Yeah, I need one of them to disappear, and they don't yet. So what I'm going to do in each of these cases is I'm going to find where there's a plain old x or sometimes a plain old y, and I'm going to try to find a number that will make this work for me. So here's how this goes. And in this case, I'm going to keep the top one the same. But the bottom one, I want this to be negative 3x. That's my goal. So the question is, how am I going to get it to there? Well, it's already negative 1x right here. So what can I multiply negative 1 by to end up with negative 3? 3. So I'm going to multiply this bottom equation by 3. So here's how it works. 3 times the negative 1x, negative 3x. Sweet, that's what I wanted. Because now I'm going to be able to cancel the x's in a minute. 3 times 3, positive 9y. And 3 times negative 5 is negative 15. By multiplying through by 3 that time, now when I add down, 3x and a negative 3x cancel. That's good. I need to eliminate one anyway. 2 plus 9, 11. 4 plus negative 15 is negative 11. And what's my one step to get y by itself? Divide by 11. So you'll notice the only step that's different from yesterday is I'm going to multiply one of the equations first. Otherwise, it's the same. And then just like I did yesterday, I'm just going to keep using the top equation. So I'm going to write that down. Then I'm going to say, okay, I know what y is. There's y. It goes right in here. So the y is going to go away, just the y part. And it's going to get replaced with the number that I have circled. Straight substitution. And that's going to become an equation, a regular old two-step equation that I can work with. So what we're going to do is we're going to end up trying to solve this now for x. So what do I need to do first? I want to get 3x by itself. How do I get the minus 2 out of there? Okay? And again, this can be a bit of a longer process. I totally get that. That's why we're not doing like 20 of these a day. That'd be like crazy. And then divide by 3. But this is why when you're dealing with something like this, it's a more complex thing to think about. Businesses have to use things like this to figure out, when they're going to break even, or how much money can they make on something. Do I want to sell T-shirts at this or sweatshirts for this much? And how much do I have to sell, before I can start making money? This is the type of math that goes into that. That's why the accountants and those guys make big bucks. So it's the same thing dealing here on the next one. If I try to add down x and 2x, yeah, that doesn't cancel out. Y plus negative 3, that doesn't cancel out. So I notice there's a plain old x. So I'll leave the one on the bottom alone. So up top, okay, yep, I'm just looking for one of the equations where I have plain old x or plain old y. So if I want to get rid of x, I want this to become negative 2x. So then negative 2x plus 2x would go away. So what do I have to multiply x by to get to negative 2x? Not a trick question. It is a trick question. X times what gets me to negative 2x? Negative 2, okay. So I'm going to multiply that negative 2 all the way through here. So there's my negative 2x. Sweet, that'll cancel out in a minute. Negative 2 times y is negative 2y. And negative 2 times negative 2 is positive 4. And now it's just like yesterday. Because now I can add down 2 plus 2, see you later. Negative 2 plus negative 3 is negative 5. 4 plus negative 9 is negative 5. And what's my one step to get y alone? Divide. Get my y and then just plug that bugger in. So again, I'm going to take the top equation. And as you get more comfortable, you'll be able to start skipping some things here. Y goes away. It's replaced with 1. That's where the little substitution part will come into play here. Nope, it'll work out the same for the answer every time. So if you find an equation looks easier, you can absolutely go with that one. You can absolutely pick which either equation you want to plug into. That's how I end up with the answer. But there's always on these going to be one that I have to multiply by. Now when we get to start doing some more of these later today and Monday, I'm going to kind of blend them, the ones from yesterday and the ones from today. So sometimes we'll be able to just add down. Okay, kind of start working away at it. Nice. So, once I've done this, I think I'm going to find one more here on the back to take a peek at. Then we'll see how we're doing here. We'll work on a few of the homework ones together. Let's see. Well, I can end up with 0, but it still could end up equaling 0 on something. That could absolutely happen. Yep, it absolutely could. So, let me find one. I'm thinking 6 is looking like a distinct possibility. Yeah, let's try that. Let's do 6. Let me bring this down a little bit. Alright, number 6. Unfortunately, again, adding down not an option. But I see this plain old x up here. Now, sometime it may be y, and that's okay too. So, okay, since that's the one I'm going to change, I'll leave the bottom one alone. Okay. Let's come down for a minute. Good call. What happens if I have x and y that are just kind of no number in front of them? I can pick which one I want to use. Because either one would be a good choice there. So like for instance on 4, maybe I look at that and I say, well, if this was negative x and negative x would be a good idea. Okay, let's just look at it this way. Which one would you prefer to get rid of? Because when I have both of them, I can do, okay, the top one, and do I want to get rid of x's or do I want to get rid of y? Okay, so if we decide we want to get rid of y, it's just sitting there by itself. We can decide then that we're going to leave the bottom equation alone. And up top, if I want to get rid of the y's, since this is positive 2y, I want this to end up being negative 2y. So, well, because if I want to try to eliminate y, those just have to be opposite, so when I add down, they cancel. So if I have negative 1y already, what do I times negative 1 by to get to negative 2? 2. So I'm going to multiply the top equation by 2. And that 2 goes to everything. 2 times. How I figure this out? Figure out that number. Here's what I'm doing. Let me do this instead. Actually, let me grab a card. I'll just kind of put it over here. Let's think of it this way. When I'm doing these, okay, I have negative 1y here to start with. My goal is to make it negative 2y, so it'll cancel. That's what I'm kind of thinking about here. The question is, what can I multiply this negative 1 by so it becomes the number I need so when I come over here to add down, they cancel. So negative 1 times positive 2 gets me to negative 2. Whatever this number is the number I have to multiply everything by in order negative. Okay. I'm going to have to keep thinking here because my brain's not coming up with another way to explain it. Yeah, I will keep thinking here. I will keep thinking. I will find a way to make this work. Because once I get those set, now I can add down. 2 plus 1 is 3. Negative 10 plus 4 is negative 6. And then I can just finish it up. Do my divide, I'm going to have my x. And again, once I have that, I can plug that into either one. It doesn't matter. I just keep doing the top one just to be consistent. So if I decided I was going to do the top one, this time I have x, so it goes in where x goes. So I plug the -2 in there. What would I do now to work on getting y by itself? How do I get that -2 out of there? +2. And one last step, because y is not quite alone yet. What's the opposite of multiplying by -1? With y. So what I want to do is I want to help out some on some of the homework ones. This sheet, okay, again, that we're working on here, and anytime you see or hear something, and you're like, ooh, that'd be good to know later on a quiz, you can always write that stuff on here. But this is notes. I don't need this. You don't have to finish the rest of them on here. This is just to give you some examples to work with if you need that extra little boost, that extra little bit of help on something. What we're going to do for the actual work, okay, this is my homework, is to work on some of these. Now, as it mentions up at the top, some I can just add down and do my thing like I was yesterday. Others, I'm going to have to multiply first. So if I look at the first one, always look to see if you can add down and get rid of a variable. Well, 2 plus 1, well, that's 3. They don't cancel. But look at my y. Does -1 plus 1 cancel? Yeah. So I don't have to multiply this time. They cancel each other already. And then I can just add down and go about my business. 2 plus 1 is 3x. 5 plus 13 is 18. And what's my last step to get x alone? It always is the last step. My x, and then again, I still have to have my other variable, so I can choose to use either of these. Oh, let's really get crazy. Let's use the bottom one. X plus y is 13. Yeah, you can use either. If one looks like it's going to be simpler, this one I just don't have to multiply by anything, so I'm like, well, try it. Let's be different. But yeah, either one would get you the same answer. 6 y is 13. And just minus my 6. Okay, now let me just show you. I can show you that just so you can see either will work. This time I used the bottom equation when I plugged in. Now let's just say I use the top one, because I can show you both. If I would have used the top one here instead, so I'd have had 2x minus y equals 5, and I still could stick the 6 in right here. You're right. If I chose to do that one, I would multiply the 2 by the 6. You're absolutely correct in saying. And I'd multiply those together. And I'd go about doing it like I did the other one. And I'm going to get the same answer. This one just ended up being an extra step or two. So I just thought the other one looked a little easier. So that's the one that I had gone with. But you see, I get the same answer either way. So there's not a right or wrong equation to plug it into. So some of them, always check first. Some of them, that'll happen. Other ones, not quite so lucky. So like if we were doing number 2, well, 1 plus 4, that doesn't cancel out. 1 plus 1, crap, that doesn't cancel out either. So I'm going to have to multiply on this one. Now, sort of like what Maddie noticed on that last example we've done, what happens? I got x and y by themselves. I can pick either. Okay? So let's just say, I don't know, let's just say I decide I'm going to do x this time. So I'd say, okay, leave the one alone that I'm not going to do any multiplying to. But up here at the top, I need to multiply this top equation by something. If I'm going to try to get rid of x, since this is positive 4x, I want this one to become negative 4x. So what I've got to figure out is, what can I multiply x by to get to negative 4x? In this case, that would be negative 4. Because negative 4 times x is negative 4x. So that's going to take care of those for me. Negative 4 times y, negative 4y. Negative 4 times negative 3 is positive 12. And like I said before, when I go to add, the x's cancel. Negative 4 plus 1 is negative 3y. 12 minus 12 is 0, and that's okay to have happen. Because what happens when you divide 0 by anything? Negative 0. And just like we've done before, okay, let's say I stick with the top one here. So x plus y equals negative 3. I'm going to plug that 0 in for y this time. So x plus 0 is negative 3. Well, that 0 doesn't do much of anything. So that's how my x ends up. Okay. So those are the only two things that can happen on this page. Either I can add down right away, cancel a variable, and go, or I may have to multiply one of the equations. I'll even tell you what I'll do. I'll even give you a heads up here. The ones that you have to do multiplying on would be 4, there's going to be a bunch here in a row. 4, 5, and 6 all need to be multiplied. 3, you'll be able to do it down right away. And then on the back, let me scan back out here a bit so you can see more of the sheet. Now it's gone into crazy mode. I'll give it a minute to get its act together. Okay. Number 7, we're going to do some multiplying. 9 and 11. Oh, it's looking basically like that. Oh, and 14. Okay. So about half of them you're going to be able to just add down like we did yesterday. The other half you've got to multiply by something. And like I said, we're going to be spending Monday and Tuesday kind of going back through some pages where we do a little bit of both on these. Do a little bit where we multiply, a little bit where we add, a little bit where we graph, and we kind of blend them all together. Get them ready that way. So you got about 15 minutes to work with. Even if it's just knocking out 3 or 4 of them, it'll really help you to kind of reinforce what's going on. If you just shut down now and go, yep, I'm good, trust me, when you go to look at it later, it may not make so much sense. So try some out. If you're having issues, okay, let me know. I'll help out. I'll try to do what I can to kind of get you on the right track. And again, the quiz will end up being Wednesday, and the homework from this unit is going to be due by Thursday. So please be working on it if you haven't.